Before we try to understand phasor, let's recap CountDownLatch and CyclicBarrier. So let's start with CountDownLatch. Here we have a code where we want the main method or the main thread to wait for three dependent services to initialize. Only after those three dependent services are initialized, we want this thread to proceed further. For that, we are creating a CountDownLatch. The CountDownLatch we are initializing with the count of 3 because there are 3 dependent services. And we are running these dependent services on an executor service so that they run on separate threads. The executor service itself is of type fixed thread pool and the count of threads is 4. The dependent service itself is a simple runnable, and in the run method, when it does the initialization, for example, if it's a database service, the initialization could be connect to the database. Once the database is connected to, then it will say latch.countdown. So that dependent service will say, okay, my initialization task is completed, so I am doing a countdown on the latch that was given to me. So that thread itself will not stop here, it will continue with its other operations. It's just saying that my initialization work that you were dependent on is completed. When the other two dependent services also do their initializations and do the countdown latch, only then the main method, which was waiting, which was saying await for this latch to be completed and do not proceed further until that happens. Once these three dependent services say countdown, then the count of that latch becomes 0 and the main thread can proceed ahead of this await condition. So to recap, we have a latch, we have the count as 3, we start 3 services and we say latch.await. Once the 3 dependent services say okay, latch.countdown, our work is completed, the latch will be broken and then the main thread can proceed further. Visually, this can be represented like this. So main thread has count 3, it'll start 3 dependent services. Those 3 services can at different points in time say countdown. Once the last thread says countdown, that's when the latch count becomes 0 and only then the main thread can proceed further. Let's move on to the cyclic barrier. In CyclicBarrier, we have a different use case. Now, let's say we have a game, there are 3 players in the game, and we want to repeatedly send a special message to all 3 players. But we want to ensure that we send a special message to all 3 players at once to avoid any discrimination. The way we do that is we set up a cyclic barrier, we set the count of the threads or the tasks involved as 3, and then we pass that same barrier to the 3 tasks, and those 3 tasks themselves are running an executor service, again of fixed thread pool, and the thread count is 4. And this task is running in an infinite loop, and that is on purpose because we want this task to be running repeatedly. Here, each of these 3 tasks running in 3 different threads will say barrier.await. They can say barrier.await at different points in time. But once all 3 threads have come to this point in its execution, only then all 3 threads will continue doing their operation. So here, these 3 threads could take different times in arriving at this location of the barrier. But all 3 threads will have to wait until all 3 of them arrive here. And once all 3 of them arrive here, they all 3 can continue sending the message, that special message, through all 3 players at once. Once they have sent it, since this is in while true, processing will continue back and all 3 threads will try to arrive at this barrier again at the same point in time. To visualize this, we have a main thread. This time the main thread will just start the task and it has no other operations to perform. And all 3 tasks are supposed to arrive at that barrier. It's possible that the first task will say await very soon, but since the other 2 threads have not arrived at that point, the first thread will wait. The second thread could arrive a little later, but still the third thread has not arrived, so it will again go into the wait state. And the third thread, as soon as it does an await operation, that means that all 3 threads are ready to perform the task after the barrier. So that barrier is now broken and all of 3 tasks can continue their operation, which in this case is sending that message to 3 players in the game. And since this is a cyclic barrier, as the name suggests, it's cyclic in nature, you can use the same barrier to repeat this whole cycle again. Phasor is a class which can act as a countdown latch, which can also act as a cyclic barrier, and it has much more flexibility than both of them combined. So let's see how we can use a phasor as a countdown latch. So we have the same code that we had earlier, but instead of countdown latch, we are using a phasor here. Initializing the phasor similar to countdown latch, we are saying new phasor, and there are three parties because there are three dependent services. All those three dependent services are given the phasor. Those dependent services, once their initialization is complete, instead of doing a countdown method, which we were doing earlier, they'll say phasor.arrive. Similar to the countdown latch, they will not block here. It will continue to do their other operations, but they are just saying, hey, the initialization task that you were waiting for is completed from my side. And in the main thread, we have the phasor.await advance. As the name suggests, it's awaiting the advance of that phase. And it is similar to the countdown await method. So once all these three dependent services say, okay, I have arrived, that means that I have completed my initialization task, only then the main thread will continue further. Very similar to the countdown latch. The behavior is exactly the same. It's just that the methods are slightly different. Same thing as before, like the countdown latch, we initialize, here we say the parties instead of threads. It's a different terminology, but it means the same thing. Parties count as 3, and all 3 services will, once their initialization is complete, they'll say arrive. And since these lines are solid, that means that they'll not block at anything. They're just saying that, okay, my initialization task is done. And as soon as the last thread says, okay, my initialization is also done, the main thread, which was doing an await advance, can continue its rest of the operations. And this first time when this await advance completes, this phasor has this concept of phase, which we'll see much better when we see the cyclic barrier. But in this case, this is known as the phase 1, the first time the phasor hits an await advance. Now let's try to code cyclic barrier using a phasor. The code for this is very similar to what we wrote for cyclic barrier. We're initializing the phasor with the party count as 3. We're giving this phasor to these tasks that we are going to run repeatedly, and we are submitting these tasks to an executor. Here, since the main thread is not doing anything else, it will just go to sleep. And since the tasks have to run repeatedly, they are run using the infinite while loop. And here, each task will say phasor.arrive and await advance. And this method is very similar to barrier.await. This is saying, okay, I have arrived at this point, but I am waiting to advance further. I am waiting for other threads, the other tasks like me, to arrive also at this point. Only then I'll go further. This same as barrier.await. As soon as all 3 tasks arrive here, we can perform the same operation. So in this case, maybe we are sending the same special message to all 3 players in the game at once. To see it visually, again, the main thread which starts the task, main thread itself doesn't do any of the operations, and the tasks themselves will perform some operations. They'll arrive up at a particular point and they'll say, okay, I have arrived at this point and I'm awaiting advance, and I'm waiting for other threads to arrive at this point as well. So here the thread 1 comes earlier, the thread 2 comes a little later, and the thread 3 comes last. But as soon as the thread 3 also says, okay, I have also arrived and I'm awaiting advance, that's when the barrier is broken. So in this case, we are using phasor. So here we say the phase has changed. So initially the phase was 1, it was the first phase. Now we'll start the phase 2. All 3 tasks can perform their next operation, which in this case is to send that special message to the players. And since here the phasor is working like a cyclic barrier, it will repeat the whole cycle again. In the second cycle, the phase number will change from phase 1 to phase 2. This is how you can use the phasor as a cyclic barrier. There are also some special extra additions to the phasor. Phasor allows you to register in multiple ways. So here we are saying new phasor, and we are giving it the number of parties involved, the party count as 1. The main thread is starting 2 services and giving the phasor. The 2 services themselves can do the registration dynamically. It need not be at the start as part of the constructor. any thread at any time which has this phasor can register themselves to the phasor and then perform the operations like arrive and await advance, and so on and so forth. And the main thread here can say arrive and await advance. Similar to a barrier, it's saying, okay, I have arrived at this point and I'm waiting for others to arrive as well. Also, at any point in time, you want to increase the number of threads registered, the number of parties registered. You can also call this method called bulk register. In addition to the three parties, so the one is the main thread which registers itself. The next two are the services which register themselves. So the count has become 3, and here we are adding 4 more parties, so the final count will become 7. So now this phasor has 7 parties registered. And similar to how we have this register operation, we also have a deregister operation. So let's say we have a task, and based on some condition, it doesn't want to participate anymore in that phasor. For that, we have this method called arrive at this point, and then we deregister. So it will not participate anymore in the next cycles of this phasor. So these dynamic registration and deregistration is not part of either the countdown latch or the cyclic barrier. To visualize this, we have this main thread which registers itself by saying new phasor into bracket 1, the party count. It can also do bulk register of extra 2 parties. Of course, like before, it can say arrive and deregister. It's deregistering itself. A party can arrive at any point in time. If it has the phasor instance, it can say register myself, and then it can perform any other operations like arrive and await. And once all the parties have come at this point using arrive and await or arrive and deregister, the phase changes and this whole cycle can repeat. So to recap the methods available for the phasor, to register we can do it using the constructor, register method, and bulk register. And the other methods which we use to behave like cyclic barrier and countdown latch is arrive, which is similar to countdown in the countdown latch. We have arrive and await advance, which is similar to await in cyclic barrier. And we have arrive and deregister, using which we can dynamically deregister parties at any time. There are some more methods that we have not discussed, but at any point in time, a party can also say get phase, which gives the current count of the cycle. So if you are using it as a cyclic barrier, it will give you the count of the cycle which is repeating, which is also known as the phase. You can also say get me the count of the arrived parties, get me the count of parties which have not arrived yet, and you can also override a method called onAdvance. OnAdvance is a method which is run as soon as the phase changes. So if all the threads who are waiting for that phase change to happen, as soon as the phase change happens, you can have a method which is run, and which is very similar to using barrier action if using cyclic barrier. There are 2 more methods: force terminate, which can be used to terminate the phasor completely, and there is terminate method where the threads can check if the phasor has terminated and perform some operations. That's it. Phasor is a simple class. It acts like countdown latch. It can also act like a cyclic barrier, and it has much more flexibility in terms of deregistering and registering dynamically by any parties at any time. Thanks a lot for watching. See you in the next one. Bye.